So I did not save a copy of the review, so I can't upload it to my notes, and I'm sorry. But what I will do is I'll try to remember the 10 questions and tell you how to do each one of them. So I forget the numbers that are labeled in number 1, but you need to label from theta the opposite side, the adjacent side, and the hypotenuse. Once you do those, you're ready to set up your sine, cosine, and tangent ratios. So for sine theta, you just need to put the opposite side on top of the hypotenuse and then reduce. And if you forget how to reduce, you just press math and enter in the calculator, and it will reduce the fraction for you. For cosine, you need the adjacent and the hypotenuse, so you put down the numbers for that and reduce. And for tangent, it is the opposite on top of the adjacent. I can't really remember the numbers that were being plugged in. I know there was a 48 and an 80, and I forget what was what. So just put them where they go and reduce them. For problem number 2, you could use your special right triangle tables to figure this out, or you could look at the angle we're given, which is this one, and from there we have the side opposite and we have the hypotenuse. So that makes me think of SO from SOHCAHTOA and the fact that we need to use sine 45. We will plug in x for the opposite, we'll plug in 60 for the hypotenuse, and now we need to think about sine 45. 45 is a special angle. We know from the unit circle that sine 45 is the square root of 2 over 2. So I'll replace sine 45 with that, set it equal to x over 60, and now I'll cross multiply to solve. So 2x will equal 60 times the square root of 2, and to solve for x we just have to divide both sides by 2. We're allowed to divide the 60 and the 2, so the final answer here is 30 square root 2. If you read this story problem, it tells you to draw a right triangle, so that's what I'm going to do. Now we need to label the information they gave us. They said the airplane has an angle of ascent, so that it would be from the ground up of 15 degrees, and it said the plane has an altitude of 20,000 feet. Altitude is a vertical measurement, 20,000. What we're trying to do is find the distance on land for the plane to make a landing. So we're trying to find that part right there. So let's figure out what we have. If the 15 is the angle we're going from, we have the side opposite and we have the side adjacent. The hypotenuse we don't even care about in this problem. So which trig function uses O and A? Comes from TOA, so we're going to use tan. Tan of what angle? 15. We set it equal to 20,000 over the side we're trying to find. Now there's nothing special about tan 15, so you're going to have to plug it into your calculator, and I think you get 0.2679 when you do that, when you type tan 15. So we'll say 0.2679 equals 20,000 over x. We will turn this side into a fraction and cross multiply. So we'll have 20,000 equals 0.2679x. Divide by 0.2679 on both sides. And the answer here was 74,655, I think. I don't know about the 6, but I know it ended in a 55 when you round it to the nearest foot. Problem number 4 wanted you to find all 6 trig ratios. So what we're going to need to end up with is what sine theta is. And I think this one was theta. We'll need the reciprocal of that, so cosecant theta. We will need cosine and secant, and we'll need tangent and cotangent. But before we can do any of those, we have to solve for the third side. We know this side's 8, we know this side's 6, we're trying to find that missing side. So off to the side, we're going to do the Pythagorean theorem to solve for the missing side. We'll put 8 squared and 6 squared, set it equal to c squared. 8 squared is 64, 6 squared is 36. Those added together equal 100. And you square root both sides to get 10 for c. So we're going to put that right there. Now what we need to do is label from theta the opposite side, the adjacent side, and the hypotenuse. Now we will plug them into the trig ratios. So opposite theta is 8, and the hypotenuse is 10. So this reduces to 4/5, and we flip it over to get cosecant, 5/4. For cosine, it will be the adjacent, so 6 over the hypotenuse. So that reduces to 3/5, and secant is 5/3. Last tangent is O on top of A, so 8 on top of 6. That reduces to 4/3, and cotangent would be 3/4. So looking at these final answers, I can't remember if I got the 8 and the 6 on the correct sides. So if sine and cosine are flip-flopped on your answer sheet, that may be the way it was supposed to go based on the original problem. So if this is what the triangle looked like, that's how you would get the answer. So if it's different on your papers, then adjust it accordingly. Problem number 5, we have to solve for theta. We want to know what's that angle. So to do that, we have to get rid of this tangent. We do that by inverse tangenting it. Inverse tangenting it. It's not even a verb. You take the inverse tangent of each side, and we will type it in the calculator. You type in second tan so that shows up on your calculator. Put in the 1.5, and it will tell you it's about 56.3 degrees. Number 6 wants angles that are coterminal with 68 degrees. So all that means is they end in the same place as where 68 degrees is. So 68 is kind of like right there. They really want to know is how could we take the long way to get there? We could start right here and just go straight to 68. But what else could we do? Well, we could go past 68 and keep going around the circle an entire another time and get to the same place. If we did that, we would take 68 and we would add the full circle, which is 360. And if we totaled that up, we would get 8 to 428 degrees. That would be one answer that's positive. To get an answer that's negative, let's start at 68 and this time go around backwards. So we're going to start there and go backwards and end up at the same place. So we'll take the 68 that we started at, and this time, since we're going in reverse, we're going to subtract 360. When you do that, you get negative 292. And that would be an answer that's negative. So long story short, take your angle, add 360 and subtract 360. Number 7 wanted the reference angle for 130 degrees. So where's 130? It's about right here. Reference angles are like, what would it be if it was in the first quadrant? So if you imagine we fold along the y-axis and kind of flipped it across, we're basically trying to figure out what is this angle but in the first quadrant. We can do that by just figuring out the distance between the angle and the x-axis, because from here to here is the same as it would be from here to here. So let's take that 130 and the 180 that's down here and find the difference. So 180 minus 130 gives us 50 degrees. It's 50 degrees from here to here, so a 50-degree angle would be the reference angle for 130. I'm sort of having trouble remembering what number 8 was right now, so if I think of it later, I will go back and edit. I think number 9 was find the sine of 225. If it's not, then do something similar. 225 is down here in the third quadrant, and it's right in the middle. So we refer to the angle that's right in the middle in the first quadrant. We refer to 45, and I know the coordinates for 45 are square root of 2 over 2, square root of 2 over 2, which means down in the third quadrant, we'll have that coordinate, but they will both be negative. Yes, you will get a unit circle to use on the test tomorrow. So if we want sine, we just want the y value, which means negative square root 2 over 2 would be the answer. I can't remember if number 10 was sine or cosine 210, but I believe it had something to do with 210. So let's think about 210. It is right here. So what angle do we refer to for that? Well, if you think about the reference angle, how far away it is from the x-axis, that's 30 degrees away. So we'll use 30 for our reference angle. And when we think about 30, it's the square root of 3 over 2, comma 1/2. So down in that third quadrant, everything is negative. If this question was looking for cosine, then our answer would be this, negative square root 3 over 2. If this question was looking for sine, then the answer would be negative 1/2. So again, I apologize that I didn't have all those questions in front of me, but I hope that helped you with some of those questions.